All right, so are you ready to go deeper? Because today, we're diving into the architecture of the internet itself.
We're talking the protocols, those languages that let computers actually talk to each other online.
Uh-huh.
And to help us, we have an expert who, dare I say it, eats network technologies for breakfast.
I'm more like a healthy curiosity, but I'm with you.
Okay.
There's something fascinating about the systems we build that make online communication even possible.
Right.
And this document, Introduction to TCP IP Complete, this gets right to the heart of it.
It does. And you know what? We're not even talking about, like, browsing the web today, right? We're
Yeah.
going deeper than that.
Yeah.
We're talking about all the invisible stuff that makes browsing possible, like at all.
Yeah.
What's the foundation here?
Exactly. So think of it like this. The internet needs rules. It needs like a common language
Right.
for all these devices to connect and share information.
Okay.
That's where the TCP IP suite comes in.
Okay.
It's the bedrock, the set of protocols that underpins like everything.
Wow.
Without it,
Yeah.
chaos.
Okay, so TCP IP, is it like the internet's operating system almost?
Mm-hmm.
But how does it actually work?
It's beautifully organized, actually.
Okay.
Imagine a cake, right?
Okay.
With layers.
Okay.
Each layer in TCP IP has a specific job, and they work together, like
Huh.
seamlessly.
Wow.
So you've got your application layer,
Right.
which is where the data you actually want to send lives, your email, your cat videos, that's all up there.
So that's like writing the letter before you even put it in an envelope.
Perfect analogy. Now, the transport layer, that's like the envelope. It gets your data ready for its journey.
Mhm.
It adds the addresses, makes sure things arrive reliably.
Right.
Like, are you going to choose registered mail, or are you just going to hope for the best?
Yeah, exactly.
That kind of thing.
Got it. So we're getting organized.
Yes.
Then what?
Mhm.
It just like beams itself across the world.
Not quite. The network layer is where things get really, really clever.
Okay.
It figures out the most efficient path for your data, like a GPS for your digital package.
Wow.
It's dealing with IP addresses, routing.
Mm-hmm.
Think of it like the postal service's behind-the-scenes magic.
Makes sense. So we've gone from the content itself down to the postal service level,
Right.
but we're still missing the actual mail carrier.
Right, precisely. That's our link layer, the physical connection.
Okay.
This is where you get into Wi-Fi, Ethernet cables, the hardware that actually transmits the ones and zeros.
Okay, this is an elegant system, I have to say, right?
Yeah.
It's pretty cool, but history is full of things that look good on paper but fall apart in the real world.
Oh, yeah.
Early internet,
I mean-
anything come to mind?
Oh, absolutely. One story that always gets me is about the second version of the NSFNet backbone.
Okay.
Essentially like a major internet highway.
Right.
They launched it, and within months, it was overloaded.
No.
Bandwidth completely slammed.
Wait, seriously?
Yeah.
How did they not see that coming?
It highlights just how explosive the internet's growth has been.
Right.
Back then, the internet was mainly researchers and academics.
Oh, right, yeah.
No one predicted how quickly every day people would be on it, you know?
Yeah.
How much data we'd be pushing around.
That's wild. We're talking pre-Wi-Fi, pre-smartphone. It makes you wonder, if we hadn't figured out how to scale things, would we even aid those things today?
That's a question for a different deep dive.
Right.
But you're hitting on a crucial point. The internet's evolution is as much about human ingenuity as it is about technology.
That's a good point.
We'll get into some of those solutions, like NAT, which is way more impactful than its name suggests.
Okay, now you've got me really curious.
Oh.
We're going to take a quick break, but when we come back, we're digging into those specific protocols, the nuts and bolts of the internet language. Don't go anywhere. And we're back, ready to, like, decode more of this hidden language of the internet. We've got our metaphorical hard hats on, ready to tackle these specific protocols that you teased before the break.
Excellent. Now, where we left off, we were talking about the network layer, right?
Right.
The internet's postal service.
Right.
And just like any postal service, they need addresses.
Right, IP addresses. It's funny, most people have heard that term, but I bet very few could actually explain what they do.
Yeah. It's deceptively simple, like on the surface.
Okay.
Every device on the internet needs a unique identifier, a way to say, hey, send the data here. That's your IP address.
Okay, but we're not just sending data to one other computer, right?
Right.
It's not like a one-to-one phone call. The internet's this, like, mess of interconnected networks, right?
Exactly. And that's where things get a little more complex,
Okay.
a little more interesting. We have these things called subnet masks, which help break down large networks into smaller, more manageable chunks.
So like zip codes for the internet helping to narrow down the destination faster.
A good way to think about it, yeah. Routers, which direct traffic across the internet, use subnet masks to figure out the most efficient path for data packets. It's all about speed and efficiency at this level.
Okay, starting to get a feel for the organized chaos here.
Yeah.
But there's one thing that's always bugged me. We have billions of devices online, but IP addresses aren't unlimited, right? Did we read out like years ago?
You've hit on one of the internet's greatest hacks. Network address translation, or NAT. And it's way more important than its name lets on.
Okay, lay it on me. What's the magic behind NAT?
Okay, so imagine your home network, right? You might have multiple devices all sharing the same Wi-Fi.
Right.
But to the outside internet, they often appear as one device with a single public IP address.
Wait, seriously? My router's doing, like, digital sleight of hand.
Precisely. It's acting like that receptionist we mentioned earlier.
Right.
Taking in requests from multiple devices and making sure they get to the right internal destination. This way, we don't need a unique public IP address for every single device.
That is brilliant. And here I thought it was just some boring technical thing. Okay, so NAT is like the internet's space saver. What other tricks have we got up our sleeve?
Well, while we're on the topic of addresses, we can't forget about ARP, the Address Resolution Protocol. Think of this as the detective of the network layer.
Oh, intrigue at the protocol level. Tell me more.
Okay, so you've got your IP address, your street address, if you will.
Okay.
But at the hardware level, each device also has a unique MXC address. Its physical address, like a fingerprint. ARP is what connects the two.
I think I've seen my device's MC address before, usually when connecting to Wi-Fi or something.
Exactly, yeah. When a device wants to send data to another device on the same local network, it uses ARP to find out, hey, who has this IP address?
Right.
What's your MC address so I can send this directly to you?
So it's like matching a name to a face,
Yeah.
but for devices.
A perfect way to put it. Now, there's another protocol that's often working behind the scenes that deserves a mention.
Okay.
DHCP, the Dynamic Host Configuration Protocol.
All right. DHCP vaguely rings a bell. It's got something to do with those IP addresses we were talking about, right?
You bet. DHCP is like the automated address book of the internet. Remember how we said every device needs an IP address?
Yeah.
Well, DHCP takes care of assigning those addresses automatically.
Oh, wow.
So you don't have to do it manually for every single device on a network.
So it's like a little network admin, just running around, making sure everybody's got the right ID.
Exactly. It makes connecting to a network as easy as plugging in your device and letting it do its thing. Saves everyone a lot of headaches, believe me.
But there are security implications to consider too, which is a whole other discussion.
And we might have to save that for another deep dive because we're almost out of time for this segment.
Indeed.
Yeah.
But the key takeaway here is this. We're starting to see how these protocols working together form the hidden language of the internet.
Yeah.
They might seem like just technical details, but they directly impact how we connect, communicate, and even live online.
It's like we've been speaking this language our whole lives, but we're finally kind of starting to understand the grammar.
And that's pretty powerful stuff. We'll be right back after a quick break to explore just how impactful these seemingly kind of small protocols can be. Stay tuned. We're back, and my brain is, like, buzzing. Who knew protocols could be so fascinating?
Right.
We've gone from the big picture layers of the internet down to these almost microscopic protocols, and I don't know, I'm starting to see how it all fits together.
It's like we zoomed in on a circuit board, right?
Yeah.
And found this whole world of activity, isn't it? Each protocol playing its part, these tiny interactions enabling global communication.
Seriously. Makes you appreciate that send button a lot more, right?
Right.
But also makes you wonder, knowing what we know now, like, where do we go from here? What's the next chapter in this story?
That's the million-dollar question, isn't it?
Yeah.
You know, we talked about how the internet has scaled incredibly quickly, like way beyond anyone's expectations. But that very success, that creates new challenges.
Like what? Give me an example.
Okay, well, think about the sheer number of devices coming online.
Okay.
And we're not just talking computers and smartphones anymore. We've got smart homes, self-driving cars, industrial sensors, like everything's getting connected.
The Internet of Things, right?
Yes.
I've heard that term, but it always seemed a bit abstract, to be honest.
It's becoming real very quickly. And all those devices need IP addresses, all need to communicate reliably.
Yeah.
We're already seeing strain on IPv4, the current addressing system.
And that's where IPv6 comes in, right? The next generation.
Exactly. IPv6 has been around for a while, kind of waiting in the wings. But adoption has been slow. And now it's not just about having enough addresses, it's about security, efficiency, making sure this interconnected future actually works.
So protocols aren't just these technical details, right? They're actually shaping how we live, how we experience the world.
Yeah.
And the choices that we make about them, about things like IPv6. Those have huge implications.
Absolutely. And it's not just up to the engineers anymore.
Right.
Understanding the basics, even just having a sense of how these systems work, that empowers all of us to engage in these conversations.
Yeah. It's like we've unlocked this secret level of understanding the internet, right?
Right.
We're not just passive users anymore. We can ask informed questions about things like net neutrality, about security, about the future we're building.
Precisely. And that's what this whole deep dive has been about. Not just giving you the facts, but equipping you with the context to make your own connections, to keep asking those what if and what's next questions.
So as we're wrapping up here, what's the one thing you hope our listeners take away from this deep dive into internet protocols?
Curiosity, I think. Don't take the internet for granted.
Yeah.
When you open a web page or you send a message, remember there's this hidden world of intricate systems that are making it all possible.
Right.
And don't be afraid to kind of peek behind the curtain, keep learning and exploring.
I know, I'm definitely looking at my Wi-Fi router a little differently now. A huge thank you to our expert for guiding us through this fascinating landscape. And to our listeners, keep those brains engaged, keep diving deep, and we'll catch you in the next episode.